Hello and welcome to Advent of Code Day 1. I'm gonna solve the first day using Rust. I might switch up the languages and I'm trying this new thing. So let's get into it. So, day 1. Historian Hysterian. Historian Hysteria. The chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. As each location is checked, they will mark it on their list with a star. They figure the chief's historian must be in one of the first 50 places. They look they'll look so in order to save Christmas, you need to help them get 50 stars on their list before Santa takes off on December 25th. Uh, okay. Collect stars solving puzzles. Two puzzles will be made available each day in the Advent calendar. Like every year, the second puzzle is unlocked when you complete the first. Each puzzle gets 1 star. Okay, just as it usually is. Okay. You haven't even left yet, and the group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be the chief's historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Throughout the chief's office, the historically significant locations are listed not by name but by a unique number called the location ID. Okay, to make sure they don't miss anything, historians split into two groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the two lists up side by side, your puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists, for example. Okay. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list. Then the second smallest left number and with the second smallest right, okay, and so on. Within each pair, figure out how far apart the two numbers are. You'll need to add up all of those distances. For example, if you pair up a 3 from the left list with a 7, from the right list the distance apart is 4. If you pair up a 9 with a 3, the distance apart is 6. In this example above, blah 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 blah, blah to find the total distance between add up this all the pairs found. In the example above, this is 2. Okay. Your actual left and right list might contain many location IDs, which is the total distance between your lists. Okay, I need to log in. Wait, get the thing. Okay, perfect. Perfect. What does the puzzle input look like? Okay, a long list of numbers. That seems plausible. Okay, let's get into it. Let's check that everything's working as it should. Cargo run. Oh, I haven't installed GCC. Does cargo run work now? It sure does. Okay. So my plan, make a list of these numbers on the left list, make a list of the numbers on the right list, then sort them, and then start comparing. So let's take the input. Let input equals include string. Example.text. Example.text. Perfect. Now we have our input. Let's see if that got read correctly. And let's check. That sure seems like that's read correctly. So now so split them by lines and then split them by ASCII white space. Okay, let's do that first. Let lines equals input dot lines dot collect. And that should be a vector of strings. Or it's a vec of string references. Perfect. And then that's our lines. Let's also that's the lines. We also need the two lists that I mentioned. So left column equals new vec. And then we have a right column. Maybe I should make this bigger. Which is we should give these types. And that is also a new vec. Perfect. Then for every line in lines, we need to split the line, split ASCII white space. And then we have our left and right number. I hope, does this work? Oh, why? Expect another, oh wait, can I collect? The value cannot be of type. So I think the correct thing to do is just let's let left equals. Okay, wait. We make this into a variable and then just call next on it. So let mutable, and this, what to call this? White space iterator, white space iter, and then just call white space iter dot next dot unwrap. And we should actually just parse this, and yeah, that needs to also get unwrapped. And then the right white space iter dot next dot unwrap dot parse dot unwrap. Perfect. Let's check that this is right. We should get the exact same thing if I've done this correctly. Let's run this and see. I'll make everything not as big and just boom, car, go, run. Oh, it's complaining I didn't give these types. I32. A4, 4, 3. Yeah, so we parsed this correct. So then we just push them onto the lists. Left column dot push left, and right column dot push right. Perfect, so now we have the two columns. So now we have these two in lists. So my plan is to just sort them and then pair them up and see and calculate the differences. So left column dot sort, right column dot sort. That was simple. And then just walk them together. For I in 0 to left column dot length. And then let's begin by just printing out the difference. So left column I minus right column I. Not too hard. Yeah, and it's all negative because they subtract. It's all negative because they subtracted the smallest number in the left list with small. Okay, yeah. I think they do right column minus left column. It's a bit ambiguous whether you should take the absolute value of this or just let it remove this so I can retain the result easier. It's a bit unclear if you should take the absolute value of this, but I don't think so. And then we sum it up. Sum equals 0, and then sum plus equals this. Alright, I need to output the sum. That's our answer. Sum. And then run. 11. And what's the correct answer? 11? It seems so. Let's check if we have the correct when we do the input then. Wait, include string, input the text. Let's check. Hopefully this is correct. Answer, submit. That's not the right answer. Your answer is too low. If you get stuck, okay, return to day 1. Then maybe they want the absolute value of this thing. Let's check absolute value and then run it again. We have to wait. I think this is correct though.
1 minute later.
Submit. Perfect, that's the right answer. Perfect. What's part 2? Hopefully it's not too bad. Part 2. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed different. Or are they? Cue Visa's music. The historians can't agree on which group made the mistakes or how to read most of the chief's handwriting, but in the commission, you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. Okay. This time you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number times that number appears in the right list. Here are the same example lists again. For these example lists, here is the process of finding out similarity. First number in the left list is 3. It appears in the right list 3 times. So the similarity score increases by that. Second number is 4 and it like once. Okay. And then you take the sum. Okay, perfect. So 3 appears 3 times. 3 times 3 is 9, so 9 plus 4, that's once. and then 2 that doesn't appear 0, and 1 doesn't appear 0, and 3. Okay. Shouldn't be too hard. I think what we should do is on the right column have a hash map that's just i32 to i32, where the first one is the number and the other one is the count. And then do if right column dot has or dot contains key right. So basically we're checking if we've seen the number we just parsed before, and then right column dot get mute. What does get mute return? Okay, yeah. So if we want to change, yeah, this is the one when we need get mute right, so we can change the value here, and get mute plus equals 1. Do I have to dereference this? I think I do. Oh yeah, no, I need to unwrap it first. Unwrap it, and then dereference. I think so. Yeah, dereference. Perfect. And if the key isn't contained, then we'll just push 1 into it. Is it push, or what do they call it? Set, add, insert, they call it insert right to 1, because it appears once. And then we don't sort, but when we do the sum, we go through all of the things in the left column. And now we don't even need to sort it, so just delete that. And then sum is, okay, we don't need the absolute value, but it's the value multiplied by the number of times we find that value in the right column. And if we don't find it, then unwrap or 0, because that's a reference to 0, I guess. Perfect. They should be correct, and let's try with the example first. And this should be a hash map new, not a WEC. Perfect. I think this should work. Let's check. 31. The first was 31. Then let's check that with the input. 1. This big number, I don't know. It's 18 million, I think. Is it 18 million? It's 18 million. Submit. Perfect, right answers. Closer to finding a sheep. Yep. So, perfect. Yeah, thanks for watching and have a good one.